Hello friends, in this video I am going to explain what is a resistor, what are the various combination of resistance, series combination, parallel combination, and finally we are going to compare series circuit and parallel circuit. First, let us see what is resistor. Resistor is an element having some appreciable resistance. Okay. Resistors are called passive element because they don't produce energy. They don't supply energy. Instead, they will only receive energy. That is why they are called passive elements. In a DC circuit, resistor is the passive element. Why do we use this resistor? Resistor is used to limit the current flowing in the circuit. It provides voltage difference. That is, it divides the voltage. Clear? And it is used to control the signal level, or it is used to control the current flowing in the circuit. Thereby, the light can be made dimmer or brighter by making use of this resistor. Okay. The resistors which are shown in this slide, these are called fixed resistors. Okay. There are n number of resistors in electrical engineering. To discuss that in one video, it's highly impossible. Let us focus only on fixed resistor in this video. Okay. Now let us see the combination of resistance. There are two combination of resistance. One is series combination and parallel combination. First, let us see resistors in series, that is series combination. In series combination, resistors will be connected end to end. They will be connected end to end. Fine. This is called series connection. Fine. You can find that the resistor R1, R2, R3. There are three resistors connected in series. Fine. And we are connecting them to voltage source here through a plug key, right? This plug key is in closed condition. Fine. You can see a dot. Yes, here. So it is in closed condition. And here we have a meter to measure the current, and voltmeter is connected across the combination of three resistors. Fine. Okay. So in this circuit, you find that the current flowing through this entire circuit, that is throughout the circuit, the current flowing is going to be same. It is not going to vary. Current is same. The current flowing through this resistor R1 is same as that of the current flowing through this resistor R2. Okay, the same current will be traveling to this third resistor. Okay, so in series circuit, current is same, whereas voltage divide. We have voltage drop. What is this voltage drop? That means this resistor is resisting the current, limiting the current. So therefore, there will be a drop in voltage. So the drop across this first resistor R1 is V1. And the voltage drop across the second resistor is V2. The voltage drop across the third resistor is V3. Okay. Now, when we add all these voltage drops, we will find that it is equal to the supply voltage. Can you tell me in this which is active element? Yes, the voltage source is active element, whereas these resistors are called passive element. Okay, so we are going to derive the expression for the total resistance connected in series. Okay, here in this case we have three resistance are taken. We'll have to find what will be the total resistance. So let us see the derivation part. We know that the current flowing through the series circuit is same, whereas potential drop are different. That is, the voltage divides. That is a function of resistor. So here the supply voltage will be equal to the sum of voltage V1, V2 and V3. Okay, so it is taken as equation number 1. And current is same throughout the circuit. So according to Ohm's law, how can we write this total voltage V as this total current I into the total resistance Rs? Okay, so that is this expression. And according to Ohm's law, we know that V is equal to I into R, isn't it? So the same fashion we have to write for the remaining voltage drops. What is this V1 is equal to? V1 will be equal to I into R1, because the same current is going to flow here, here also the same current, and here also we have the same current. Okay, so we can write the potential drop across the resistor R1 will be V1, which is equal to I into R1, whereas V2 is equal to I into R2. Okay, V3 is equal to I into R3. Okay, all these expressions we have to substitute in equation 1. So when I substitute all this in equation 1, what will I get? Here I into Rs, when we substitute here we get IRs, and V1 is equal to I into R1, so that we are going to substitute here V1. So V1 is equal to I into R1. What about V2? V2 is equal to I into R2, that we are going to write here, and V3 is equal to I into R3. Okay, so here instead of V3 I have to substitute I into R3. So on substituting all this we will get the expression like this, have it as equation number 3. Now what is common? Here current and here current. So current we can take it common among these three terms, and we can cancel current on either side. Fine. So we will be getting Rs is equal to R1 plus R2 plus R3. So for a circuit having 3 resistors, we can have the total resistance as sum of the resistance. If suppose if have n number of resistance, then what will be the total resistance? We have to add up to Rn. Okay, up to Rn. So starting from R1. Okay, starting from R1 to Rn. Okay, so this will give you total resistance. And how can we write in short? The mathematical expression can be written as the total resistance Rs is equal to sum of all the resistance connected in series. So summation is varying from 1 to n. Okay, so we can express the total resistance like this. Fine. So now we will move on to the next combination. What is the next combination? Parallel combination. So in this parallel combination, we have the resistors connected in parallel. What is parallel? They are connected across the two ends. See how they are? You know parallel lines? You would have studied parallel lines in mathematics. The same way here, parallel parallelly we are going to connect to the resistor, isn't it? See here, R1, R2, R3. These are the three resistors that are connected in parallel across the 2 points. And how to measure the voltage? We need to connect the voltmeter across these 2 ends, right? And now see, we are going to connect this combination to the voltage source. And here we have the plug key. As usual, we'll have a plug key and ammeter which will be connected in series. Now see how the ammeter is been connected here. The positive terminal of the battery, okay, is connected to positive terminal of ammeter. Negative terminal of ammeter is connected to the negative terminal of a battery. Negative end of ammeter is connected to negative terminal of a battery. This is how we connect a ammeter. Okay, right. So even the same way here, voltage. To measure the voltage, we have voltmeter which is connected in this fashion. That is, positive terminal, positive end of the voltmeter is connected to positive terminal of battery, and negative terminal is connected to negative terminal of battery. Negative. Fine. So this is how we connect the elements in parallel. Okay, and we can find the current as well as voltage across. Now here, what do you observe? See, the current from the battery is flowing through the circuit. Okay, and now here it divides into 3 currents. This current is I1, this current is I2, and this current will be I3. So here in parallel circuit, current divides, whereas voltage will remains the same. See here, these are the 2 ends. Across these 2 ends, the voltage is, voltmeter is connected. Voltage will remains the same. Okay, so what is the voltage across this resistor R1? The same voltage will be across this resistor R2. The same voltage will be across this resistor R3. Okay, so what did we observe? We observed that voltage will be same in parallel circuit, whereas the current divides. Okay, so now we have to see the derivation part. So let us see the derivation part of parallel circuit. What is the derivation? What we are going to find? We are going to find the total resistance for n number of resistors connected in parallel. But here we have taken only 3 resistors, so therefore we need to find the total resistance for these 3 resistors connected in parallel. Okay, so now let us see the derivation. So here in parallel circuit, we know that the current is dividing. We can call the circuit as current divider circuit, whereas series circuit is called voltage divider circuit. Okay, so since the current is dividing, we can write the expression as I is equal to I1 plus I2 plus I3. Fine. And we know according to Ohm's law that I is equal to V by R, isn't it? So how can we write the expression for total current I? That can be written as V divided by RP, because the total resistance is taken as connected in parallel, no? So we need to take the total resistance as RP. Okay, parallel connection. Fine. And similarly, we have to write the expression for current for the different resistors. Okay, so we have to find the different currents flowing through each resistor. Let us see the diagram. Okay, let us see the previous diagram so that you will understand very clearly. Here in this, this is the current I1. So how will I write the expression for I1? I1 is equal to, what is the voltage? Voltage is same, no? For R1, R2 and R3. So this is V divided by, what is the resistance? R1. Okay. So I1 can be found, I1 is the current flowing through R1 resistor, isn't it? So I1 is equal to V divided by R1. So similarly, I can write for the current flowing in R2 resistor, V divided by R2. Similarly, we can write what will be I3. I3 is equal to V divided by R3. Okay. So now we need to substitute all these expressions in equation number 5. Okay. See here. In equation number 5. So we are going to substitute that in this equation. So therefore I is equal to V by Rp, and I1 is equal to V by R1, and I2 is equal to V by R2, and I3 is equal to V by R3. Fine. So we are substituting all these things, and we have seen that the voltage is the same, no? Voltage is going to be same. So therefore voltage can be written as I1 into R1, or I2 into R2, or I3 into R3. Okay. So voltage expression can be written in this way. From this, it's easy to write, no? I1 is equal to V by R1, I2 is equal to V by R2, I3 is equal to V by R3. Here the voltage is same. That is why we are writing only V. But current is dividing. That's why we write I1, I2, I3. Okay. Hope you understood. When we have the same current, we'll write I. When we have the same voltage, we will write V. When we have different voltages, then V1, V2, V3. When we have different current, then we write I1, I2, I3. Clear? So now we'll have to substitute all these expressions. We have substituted, and you can find that the voltage is common, isn't it? So take voltage common and cancel it. Then we get the expression 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So we can write what will be Rp then? Rp is equal to 1 divided by 1 by R1 plus 1 by R2 plus 1 by R3. This is the expression for 3 resistors connected in parallel. That is the total resistance of 3 resistors connected in parallel. See, when we calculate the total resistance in parallel circuit, the total resistance will be less than the smallest of individual resistance. Okay, so this I will make you understand. Similarly, when we go for the series connection, the total resistance, okay, the total resistance is equal to R1 plus R2 plus R3, isn't it? So therefore here what happened? We have, what is that? Resistance is going to be more. Resistance is going to be greater. If you want a higher resistance, then we have to go for series connection. Suppose if you want a low resistance, means then we have to go for parallel connection. Understood? Fine. So now let us continue with comparison. So let us compare the series circuit and parallel circuit. What is the series circuit called? End to end. It is actually end to end connection, right? And the other name for the series connection is cascade connection. Okay. Parallel circuit. When we go for parallel circuit, it is connected across the 2 points. So it is called shunt connection. In series connection, current is same, isn't it? See here. I'll show you the circuit, then you can easily tell. Here in this circuit, current is same. Okay, voltage is dividing in series circuit. Fine. And in parallel circuit, you find that, 1 minute. Here in parallel circuit, we find that current is dividing. isn't it? See here, this is the current. So current, the total current is divided. So current divides, whereas voltage is same. Clear? So this is the second difference. Fine. So we have done with the two comparison. Fine. Single path for the current to flow. Yes, for series circuit we have a single path, whereas we have many paths. Okay, current is dividing, right? So it will have multiple path for the current flow. And in series circuit, if any one of the equipment is failed, that means it is not working. Say for example, if you are connecting lamps in series or LEDs in series, if one is not working, then the entire circuit is not going to get the supply because it becomes open circuit. Okay, see here we have three resistors like this. Suppose here we have, you can consider this as an LED. Okay, LED light that have little resistance, right? So if one of the LED is not burning, then the current flowing through this, what will happen here, it will become open. So no current will be flowing in this circuit. Okay, so if one appliance is going to fail, then all other will not get the supply. Whereas in parallel connection, what will happen? See in parallel connection, what happens is that if one of the LED is not working also, see if this LED is not working also, they will get the supply, isn't it? They are getting the supply. It will not affect the other appliances or other LEDs. Fine. This is the advantage of parallel connection. Okay, and we have seen the total resistance expression for total resistance. Rs is equal to R1 plus R2 plus R3. Suppose you have n number of resistors. Suppose if you have 10 resistors, R1 plus R2 till R10. So we have n resistors. So n into R. Fine. This will be the expression. Now for parallel circuit, we have the expression Rp is equal to 1 by R1, 1 divided by 1 by R1 plus 1 by R2 plus 1 by R3. This is what the expression we have already derived. And suppose if we have the same resistors connected in series, say for example here, same resistors, same three resistor value. Say for example, this is R, this is R, this is R, having the same value. Okay, so what will be the total resistance? Rs is equal to R plus R plus R. R plus R plus R is 3R. So when three resistors are connected, we are getting 3R. Suppose if n resistors are connected, we will get nR. So this expression we have written for the same resistance, having the same value of the resistance. Okay, right. Here if suppose three resistors are having the same value, then what will be the expression? Okay, that will be R divided by n. How? Let us see that. So here 1 divided by 1 by R plus 1 by R, okay, plus 1 by R. R plus, see here, take LCM. So what we will get? I will continue this in the next screen. Yeah. So how will I write? Suppose if I have the same resistance in parallel connection. So 1 divided by 1 by R plus 1 by R plus 1 by R. Okay. So now take LCM. So what you will be getting? We will get 1 divided by 3 by R. So which will become R by 3. R by 3. So when three resistors are connected, we get the expression R by 3. That means if when n resistors are connected, then we can have the total resistance to be R by n. Hope you understood. Fine. Now we will see the next difference. Total current, okay, the total current will be less in series connection because resistance is more, right? Whereas here the total current will be more because resistance is less in parallel connection. Total resistance, when we find, it's going to be less. To get the highest resistance, we need to go for series circuit. To get the lowest resistance, we need to go for parallel circuit. Okay, so what is the total resistance? R is how it will be. It will greater than the greatest resistance in the circuit. It will be greater than the greatest resistance in the circuit. Say for example, you are having 1 ohm, 2 ohm and 3 ohm. These are the three resistors connected in series. Then what will be the total resistance? Total resistance will be 3 plus 2 plus 1. Okay, which is going to be 6 ohm. 6 ohm is greater than the greatest resistance. Okay, so here the same way in the parallel connection, when we go for, as I already discussed, that suppose if we have 3 ohm, okay, so 1 divided by, what will be Rp? Rp is equal to 1 divided by 1 by 3 plus 1 by 3 plus 1 by 3. Suppose if we have 3 ohm resistors connected in parallel, 3 ohm resistors connected in parallel. So here in this case, we will get 1 divided by 3 divided by 3. That means it's going to be 1 ohm. So total resistance is going to be 1 ohm, which is lesser than the least resistance. Fine. Okay, hope you understood. The next, where do we use this series connection? We use in decoration lamp. You would have seen that during Christmas or during puja festivals like uh, Ganesha Chaturthi, we use decoration lamps, no, series lamp. So that makes use of series connection. The domestic circuit, that is all the appliances in home, okay, are all connected in parallel connection. Why parallel connection is used in domestic wiring? Because all the appliances should get the same voltage, that is 230 volt 50 hertz single phase AC supply. So this is the kind of supply which we will get in house, right? So all the equipments, maybe fridge or washing machine or fan, okay, or anything, the different loads whatever we have, all should be connected in parallel because they need to get the same voltage. And one more thing is that each equipment will be drawing different currents. So they have different rating, different current ratings. Then which kind of connection we need to go for? We need to go for parallel connection. Okay. What if we connect all these appliances, fan, refrigerator, then TV and all this, all the equipments which are there in the house, if we give a series connection, what will happen? If one equipment is going to fail, then the total other equipments will not be able to get the supply. Okay, so the advantage of connecting the equipments in parallel connection, hope you understood. So we have completed the discussion of what is resistor, right? What are the different combination of resistance? We have seen series and parallel combination and derivation of total resistance for these, and we have seen the difference between the series connection and parallel connection, applications of series and parallel connection. Hope you enjoyed the video, and if you like the video, please subscribe and share to your friends. Thank you.